Okay, so we have sine and cosine graphs, and we're also going to be doing tangent and all the inverses. So for your basic sine and cosine curves, all right, they look like mountains. So they kind of go like this, and they just keep repeating and repeating and repeating. So they go all the way from negative infinity to positive infinity, but you can take chunks of them, right? So like I have like this chunk, and I have the next chunk, and so on and so forth, or this chunk. So I've got my range goes from -1 all the way to +1, and then my period is 2 pi. That's because that's one whole revolution around my circle. So if I had a circle, this is 0, right? This is pi/2. This is pi. This is 3 pi/2. And then this is 2 pi, right? If I took that and I stretched it out, here is 0, then over I would have pi/2, and then pi, and then 3 pi/2, and then my 2 pi, right? And these points are 0, 1, or 1, 0, I'm backwards, 1, 0, 0, 1, -1, 0, and 0, -1. So if I was sitting at 0, the sign would be 0, so I have it a point there. When I'm at pi/2, it is 1. When I'm at pi, it is 0. When I'm at 3 pi/2, it's -1. And then when I'm at 2 pi, it's 0. So it makes this curve, right? That would be one period, because I went from 0 to 2 pi. Now, cosine would be all the x values. So instead of starting at 0 on the x-axis, or on the y-axis, I would be up at 1. At pi/2, cosine is 0. At pi, cosine is -1. At 3 pi/2, cosine is 0, and at 2 pi, it is 1. So it starts at the top and then comes down and goes back up. So that's the difference between the two. Now, you need your 5 key points, so I need 5 points total on my full period. So I know that if I'm going from 0 to 2 pi, that's a distance of 2 pi, and I want to cut that into 4 sections. So every section would be a distance of pi/2. So you have 1 pi/2, 2 pi/2, 3 pi/2, 4 pi/2. And that's going to come in handy later. Then you have your minimums and maximums, which is the high points and the low points. Same thing for your cosine. All right, so we're going to sketch this, and what we're going to do is we're just going to extend the graph that we had a while ago. So I know that my normal sine graph, it goes from 0 all the way to 2 pi, right? And we may want to extend this out actually just a little bit longer, because it's going to go a little farther. All right, so here's my origin, right? And if you look at what we just looked at, I'm counting by pi/2. So I'm just going to take this and extend it, and I'm going to go 1 pi/2, 2 pi/2, which is the same thing as pi, 3 pi/2, and then I get to my 2 pi, right? So every single time I'm just adding pi/2. So my normal sine curve goes from 0 all the way to 2 pi, but I want to extend it to go all the way to 4 pi, and I want to extend it to the left to go all the way to a negative pi. Well, that means this will be a negative pi over 2, negative pi, negative 3 pi over 2, and negative, oh, we're only going to negative pi, so don't go all the way out that far. All right? Now I'm going to take this 2 pi, and I'm going to keep adding pi over 2 to it. So if I take 2 pi, and I add pi over 2, I end up with 5 pi over 2. And then I'm going to add another pi over 2. And I get 3 pi. And then I add another pi over 2. And you get 7 pi over 2. And then if you add another pi over 2, you get 4 pi. So I've just taken my sine graph and I've extended it both ways. So here's the thing. If you think about it, we already decided that normally my sine graph, my basic sine function at pi over 2 is at 1. We established that sine of pi over 2 is 1. But then I have to take it times 2. So what happens is it actually stretches it up, and I'm not at 1 anymore. I'm at 2. So essentially, all you're doing is taking where you normally were on the basic sine function and multiplying it by 2. Then at pi, I'm at 0. At 3 pi over 2, if you look at this, at 3 pi over 2, sine is negative 1, right? But I'm going to take that times the 2, which gives me negative 2. And then at 2 pi, I'm at 0. Then what happens is this just repeats itself. So at the 5 pi over 2, I'm back up to 2, back down to 0, down to negative 2, and then back up to 0. Now if I extend this to the left, it's kind of like this. If you pay attention to it, you have this, and then you have a maximum, intercept, minimum. Intercept, maximum, intercept, minimum. So this direction, I would actually go down to negative 2, and then back up to 0. And then when you draw this in, you're just going to round and connect your dots. And technically, this is going to continue, so I'm going to put some arrows on the ends. So if we take a look at number 2, if you notice, and we're just going to go from 0 to 2 pi on this one. If you notice, though, on the last one, we multiplied by 2, and that made it stretch up to 2 and down to negative 2. So that means on this, instead of stretching, we're going to end up shrinking the distance up and down. So I'm going to start at 0, and then I've got pi over 2, pi, and try to make those as equally spaced as possible. 3 pi over 2, and then 2 pi. So normally, you would be at 0 first, right? This is sine. And then you would go up to 1. But because we are multiplying that value by a fourth, instead of going up to 1, you're only going to go a fourth of the way up. Then you're back at 0. And then instead of going all the way down to negative 1 like you normally do for 3 pi over 2, you're going to go only a quarter of the way down, and then back up to 0. That would be 1 period. Draw your sine curve in. And I always put arrows in the end. So if you notice, all right, this number right here just dictates how far up and down you're going to go. So if you look from here, this is like your halfway, right, between your maxes and your mins. It's a fourth of the way up and a fourth of the way down. Just like over here, this was 2 up and 2 down. This represents like what I would call like your baseline, okay? That is your amplitude. That's what we call that. So the amplitude represents half the distance between your minimums and your maximums, and you find it by taking the absolute value of that front number. So if I asked you what the amplitude of this problem is, you would take the absolute value of 1/4, and that gives you 1/4. Your amplitude is 1/4. So on this last problem, your amplitude is 2. You just take the absolute value of the number that you're multiplying in front of your function. So if that number, the absolute value of it, is greater than 1, then you have a stretch, right? It makes it taller, it stretches it up, and it stretches it down. If that number is less than 1, the absolute value of it, so in other words, it would be like between 0 and 1, then you have a shrink, which makes sense, right? Because it's like cutting it. All right. So now that we've kind of got sine under control, we can talk about cosine. So we'll start that in the next video.